Okay, so here we're given three functions that are solutions to a third order differential equation. We could verify that if we wanted to. Um, it's also true that these are all linearly independent. We're not going to prove that either here. What we are going to do is we're going to form the general solution, which is a linear combination of those three. And we're going to find constants so that that solution satisfies these three initial conditions. Okay, so in order to do that, we have to find the derivatives. Okay, so let's see, y prime would be c1 e to the x plus 2c2 e to the 2x plus, and then the third one's a little trickier, you got to use the product rule. It would be c3 e to the 2x plus 2c3x e to the 2x. So it may be worth rewriting that. Because those two middle terms are like terms. Okay. Then we got to do it again. We got to find y double prime. So what's that? That's going to be c1 e to the x plus 2 times this coefficient e to the 2x plus, and then again we got to use product rule here. So this would be 2c3 e to the 2x plus 4c3x e to the 2x. And again, we could clean that up a little bit, because again, these middle two terms are like terms. So what we have, what's the coefficient of e to the 2x? It'd be 4c2 plus, we've got 2c3 here, and then another 2c3 here, so that's 4c3. And then we got the last term too. Okay. All right, so we look at the first equation along with the fact that y of 0 is 1. That tells us that now the nice thing is when you plug in x equals 0, e to the 0 is 1. This term's going to go away actually. So yeah, we're going to have c1 plus c2 equals 1. Okay. Then we're going to look at the initial condition for y prime. Okay, if I plug in x equals 0 here, again the last term is going to go away, but I am going to have these two, so I'm going to have c1 plus 2c2 plus c3. That's going to be equal to 4. Okay, and then finally we're going to look at y double prime along with the fact that y double prime of 0 should be 0. So that's going to tell me that c1 plus 4c2 plus 4c3, that's got to be equal to 0. Okay, so here's a 3x3 system of equations. We can easily solve that by using matrices on our calculator. Okay, so let's edit matrix A. Let's make it a 3x4. We'll type in the coefficients of the first equation, 1, 1, 0, 1. Then we'll type in, for the second equation, 1, 2, 1, 4. And for the third equation, it's 1, 4, 4, 0. We want a matrix math. We want to RREF the matrix A. And let's go ahead and math frac it. Okay, no need to. So we get negative 12, positive 13, negative 10. Okay, so actually let me just so that's what the calculator, so that's C1, C2, and C3. So our solution here is actually y equals negative 12 e to the x plus 13 e to the 2x minus 10x e to the 2x. That's the solution, that's the linear combination, which is going to satisfy those three initial conditions.